So I think you'll notice as these problems go on that they tend to get a little bit more and more difficult with each problem, and that's of course intentional because the more we learn and the better we get, the more we need to be challenged in order to still continue learning new things and be interested. We don't want to have problems being just way too easy. So we've got what looks like a fairly complicated problem here. Okay, we've got 5 missing angles. As you'll notice, again, the measure of angle 4 and angle 5 went on to the next page, so I'm just writing them in below. And we're given a fairly complicated diagram where we've got a number of parallel lines. We've got actually 2 sets of parallel lines. We can label this set A and B. This will be these 2 parallel lines here, and I'll label these C and D. So we can kind of refer to them. And we've got to try to take the 2 measures we know, which is 88 degrees over here and 40 degrees over here, and somehow discover what all the different angles are just from those 2 that we know. So we have to look for relationships. We have to look for transversals in common and pairs of parallel lines. So again, I'm going to do it in order of what seems to be the easiest. I'm going to start by looking at angle 40. I'm going to try to find a relationship between angle 40 and one of the other angles. And what I see first is that angle 40 and angle 2, I'm going to call this angle 40 degrees, angle 40 degrees and angle 2 share the transversal B. And they are formed when transversal B intersects parallel lines C and D. Okay, so without going through the involved explanation, I want you to be sure and convince yourself that these 2 are both alternate interior angles, and therefore they are congruent. So the measure of angle 2 is equal to 40 degrees. Okay, now that's a big improvement now. So we've got angle 2's measurement. So not only do we need to look, or do we have to look for relationships between angle 40 degrees and another angle, now we can start to see, are there relationships between angle 2 and any other angle related to transversals and parallel lines? Take a look and see. Tell yourself if you think you see one. Okay, I'll tell you one that I see, which is that there's a relationship between angle 2 and angle 3. They both share this common transversal C, but notice they're on opposite sides of C, so they're alternate angles, and they're both between the parallel lines B and A, which intersects the transversal, so they're another pair of alternate interior angles. And therefore, they are congruent as well. So angle 3 is also 40 degrees. So take a moment and see whether or not you can come up with any other relationships. So now we can write in angle 3 is 40 degrees over here. We know 2 of our angles, but we still have to figure out angle 5, angle 1, and angle 4. Can we figure out any of them? Well, one thing you might have noticed is that angle 5 is congruent to angle 4. They are, after all, alternate interior angles, right? If we call this line E, that would be the common transversal between the 2, and line C and D would be the parallel lines. But since we don't know angles 4 or 5, we'll just have to keep that in the back of our mind. Is there any other thing that we notice here? There are actually several ways to go about getting the remaining angles. I'm going to discuss 2 of those ways. One of the things you can notice is that angle 1 and 88 degrees have a common transversal, E, line E. Okay, and they are formed when line E intersects across parallel lines B and A. What kind of angles are these? What is the relationship between the 2 of them? Are they on the same or opposite sides of the transversal? They're on the same side, right? And in addition, are they interior or exterior angles? Are they between parallel line C and D or outside parallel line C and D? They're between them. So they are same side interior angles. They are on the same side of the transversal, and they are in the interior. Same side transversal angles are supplementary. They are supplementary. So angle 1 plus angle 88 has got to equal to 180 degrees. And what angle would that be? 92. Okay, so angle 1 has to be 92 degrees because it has to be supplementary with 88 degrees, and you can check that that is the case. Okay. Well, how could we figure out angle 4? There are a couple of ways. I'm going to show you one way, and then I'm going to discuss a different way. Notice that angle 88 degrees here, plus the measure of angle 4, plus the measure of angle 3, all have to add up to a straight angle, right? They're all creating a straight angle. So we've got ourselves a nice equality here that we can use. 88 degrees plus measure of angle 4 plus 40 degrees is all equal to 180 degrees. We can combine like terms. We get 128 plus measure of angle 4 equals 180, and that gives us measure of angle 4 equals 52 degrees. Okay, so we get measure of angle 4 is 52 degrees. And we said earlier that we knew angle 4 was congruent to angle 5. We didn't know how to use it at that point, but now we can use it because they're both alternate interior angles to basically conclude that angle 5, the measure of angle 5, is also equal to 52 degrees. So these are our answers. And I promised you that we were going to look at some other ways to do this. I want you to notice that this angle here, which is angle 1, and this entire large angle here are alternate interior angles. So 92 degrees here has got to be congruent to the sum of these smaller angles on this side here. Well, that is the case because 40 plus 52 is 92. But before we figured out angle 4, we could have used that fact to deduce that angle 4 was 52 degrees. Okay, so again, we see multiple ways in which the different theorems can be used to our liking, to whatever seems convenient, but they will always independently lead to the same correct conclusions.